Hi lads, in this video I'm going to go through the orthographic projection question from page 10. First of all, it tells us the pictorial drawing of a solid shown is in figure 1.22. Part 1, project a front elevation solid, view in the direction of arrow A. Part 2, draw an end elevation, view in the direction of arrow B. Part 3, project a plan. And Part 4, project a new plan of the solid showing the true shape of surface S. So basically that question there. So to start off, I'm going to draw my three boxes to fit in my elevation, plan and end view. So I'm going to keep this to the top left of my page, as my auxiliary view is going to be going down to this side here. So my total height is going to be 50 plus 30, which is going to give me 80. Length of the elevation then is going to be 110. I can extend those lines down for my plan as well, if they won't change. Next thing is put a gap in between the two views, so maybe go 20 mil if you want. And then, excuse me, the thickness is going to be 10, 60 and 10, which is going to give me a total of 80 mil. I can take those lines at 45 degrees to give me an outline box for my end view then as a result. So you can see now, I know that all three views are going to fit on my page. The elevation, plan, end view aren't going to go any further past these outlines here. So the elevation, first thing I have is going to be a 10 mil distance going in here, and I also have a 15 mil height going up here, and those 2 points connect. And the outline is heavy then the rest of the way as well. Next thing I start to do is draw my end elevation so I can actually see where the cut occurs. So I'm looking in from the end elevation. I can see the 15 mil. It's going to be the baseline going across there, the first height. I can see them as well. They extend all the way to the top there too, and they then step in 10 mil each side. So 10 mil there and 10 mil there. So we're going down 30 mil. And then we're going to have a radius then of 30. That's going to be the halfway point between the 60 left over. And by drawing this semicircle then, it'll give me my bottom point here, which can be taken across to complete our elevation. So that's going to be hidden detail of that cut is run the whole way through. And just take our sides up here as well. So that gives us our elevation and our end view. And then to finish it off, we need to draw our plan. taking our lines down to 45, we take them across. And we can start to draw the outline of our plan. The last part of our plan we need then is our actual curve that's going to appear here. Because our semicircle here is cut at an angle, it's going to produce an elongated curve there. So what we need to do is take our points over and across by dividing them up first, using 30/60s as normal. Take them across and down to where they meet when we take them down and across as well. So what we'll do is we'll divide up 30/60 first, get a series of points, and what I'll do then is I'll use a colour afterwards to show an example of one point then. Start with 0, 1, 2, 3, 4, 5 and 6. And we just take 0 and 6 across first. They hit there. That gives us 0 and 6 there. Just let it focus. So you can see 0, 6 taken across. 0 and 6 go straight down. And we follow down 6. Gives a point here. Follow down 0. Gives us that point. Excuse me, there. And I can extend these two lines out to meet it. After that then, 1 and 5 are going to be on the same line. So we take across 1 and 5 there. We take 1 and 5 down. And same again here. We take 5 down there, 1 down there. That gives us 1 there and 5 there. 2 and 4 are also on the same line. So that's 2 and 4. And then 2 and 4 drop down there as well. So there's 2 and 4, and then finally 3. Drop 3 down, take it at 45 degrees and across, and then 3 hits at this point here, our hidden detail line, the base, and 3 is giving us that point there. Then all we need to do is draw a nice neat freehand curve and all the way around, including all those points. Just like that there. So just to show you in colour, an example there, we'll just say number 2. 2 is that point there. You take it down, across at 45 degrees, and it stops where 2, when taken across over here, hits our sloped surface where our cut is, and it goes down to meet that in plan, and that'll give us 0.2 there. That's just how to find, for example, 1 point there. After this, now it tells us to draw a new plan to show us the true shape of surface S. So basically, that surface there. At the moment we can't see a true shape bit unless we look in perpendicular to that angle there, because that view there isn't a true shape and this one here isn't a true shape either. So I need to look in perpendicular to the exact true shape. The reason why I picked this is that's a true length as well. So what I need to do is use sliding set squares, take our points down. So we want to go perpendicular to it. And what I usually do first is I take extreme points down first. So that point there and this point here. So there's no points any further than that. And that'll give me my total width. So I can take my XY line from there then as a result. I want to keep my XY line as close as possible so I have space below so that the picture won't go off the page. And I just label that X1, Y1, they're a new XY line. So the first thing I'm going to do is I'm going to start with the ground points. Taking that point there, and I already have this one taken down there, and I'll just extend it a bit more. And the difference between taking auxiliary elevation and auxiliary plan is we're going to be taking our points from our XY line going down. So I always remember we go 2 views back each time. So this is 1 view, this is 2 views. So this point here on the XY line, I go down and I can see that I have that distance there. I also have, in terms of the ground for now, if it's on the base, I have this point here. And it's the exact same from here as well. I'm going to get this point and this point. So I take the distances from the XY line down. For an auxiliary elevation, you take it from the XY line up. And I can connect those together then. And that then gives me my outline. So I can draw that in heavy. Or just the lower half first for now. So I can go heavy there. And across to there. And the next thing I'm going to focus on is going to be top section here. It can be seen. So what I need to do is take those lines down as well. So I already have that point taken down, I'll just extend it further, and I have this point as well. And they just get extended on too, they're all on the same line. We can see looking down, there's going to be this little area here and this little area here, and they're part of that surface there that I've taken down. So I need to apply my widths there as well. So I take my distance down to there. I apply for my X1, Y1. I get there, and I extend it further down to the opposite one there, and I'm going to get that point there. And that'll give us those two little boxes there as well. For the front part, we're going to have this section here, so that little rectangular area. You can't see it in the plan because it's a straight edge, but when we're looking at an angle we can kind of see it there, which is basically that little section there. So we extend that down. And you can see that that runs all the way along it. So I can extend that out there as well. And now all I've left to do is actually draw in my curved surface there then. So the first thing I do is I'm going to start with point 0 and 6. I slide those points all the way down. And I take the exact same approach again. We follow 0 and 6 down, swinging from our XY line. 0 is that distance there, follow it down, 0 is that point there, and 6 is this point here. And these two lines connect together. So it's 0 here and 6 there. And I do the exact same thing for 1, 5, 2, 4 and 3. So 1 and 5, 2 and 4 and 3. So point 1 is that distance there, point 5 is that distance there, and follow down 2 and 4, doing the exact same thing again. 2 goes there, 4 goes there, sorry, 4 should go here. 5, 4, 1, 2, and the last one, point 3. And that goes there. And once again, draw a freehand curve in. And this time what you're drawing is the true shape of that cut surface now as a result. So that surface there is the true shape that the cut makes. So to show them in colour, I've got, for example, one of my points. So for example, this point up here. I took that height, sorry, not the point there. If I take that point there and I want to find it in my auxiliary, I take the distance, for example, from there down to there. That distance is the exact same as from there to there. So remember, we measure from our XY line, so I'll mark in there, going down for an auxiliary plan, and we take our distance from our XY line as a result then. So hopefully that video helps anybody may have been stuck on it.